Good afternoon, everyone, and welcome to the second webinar hosted by the SWAN Asia-Pacific Alliance. And once again, apologies for the challenges we've had here in setting up the webinar. We'll be looking into that. My name is Hugh Chapman. I'm the moderator for today's webinar. So the topic today is the Australian Smart Water Journey, exploring the business case, and we have a great lineup of 3 speakers. Firstly, we have Peter Prevost from Coliban Water in Victoria. He'll be followed by Howard Witten from Queensland Urban Utilities, and we'll finish off with Darren Cash and Mike Wessel from Sydney Water. A few housekeeping items for us before we get underway here. The structure of today's webinar is 3 15-minute presentations, and we'll conclude with a 15-minute Q&A session once all the presentations are complete. All participants in the webinar are on mute, and if you wish to ask a question, please use the chat function on the right-hand side at any time. The moderators and administrators will consolidate the questions during the webinar and ask them of the presenters at the end. Please keep an eye on the right-hand side during the webinar. We may have some poll questions for you during the event. This event is being recorded and will be sent out to registered participants in the coming days. Before we get into our first presentation, we wanted to remind you of the Smart Water Networks Forum, and in particular, the activities of our regional alliance. The goal of the Asia-Pacific Alliance is to accelerate smart water and wastewater development in the Asia-Pacific region through SWAN's collective global industry expertise. SWAN is free to join for the first year. We'll host a number of webinars, annual workshops, and be a central source for smart water and wastewater information. SWAN members are welcome and encouraged to participate in alliance planning activities and groups and collaborate with key leaders across the Asia-Pacific region. You can learn more at the link on that page or by visiting swan-forum.com. Our alliance is chaired by George Theo, CEO of Unity Water, and we have other subject groups for those wishing to participate in the direction of our alliance. Feel free to reach out to us via the SWAN website or leave a comment in the chat with your email address if you wish to receive more information. In the short period we've had the Alliance up and running in Asia Pacific, we've managed to assemble a strong group of water utility members and other industry stakeholders, all of whom share an interest in the development of the smart water space within the Asia Pacific region. Finally, we wanted to share a few details of our first Alliance workshop, which is currently scheduled for July 2019, to be co-hosted with Unity Water on the Sunshine Coast of Queensland. We will share more information on this event in the coming months. We wanted to let you know in advance. With that, I'll hand the webinar over to Peter from Coliban Water. Peter is the Manager of Data Science, and his presentation today is on the implementation of smart metering. Peter, please unmute. Thank you.
Yeah, hi everybody. I hope you can hear me. Can I have some confirmation of that, please?
We can hear you, Peter. Thanks.
Excellent. Yeah, just with all that. Yeah, thanks to everybody for joining this webinar. And in the next 50 minutes, I'm going to join with you part of the journey that we went through as Coliban Water, implementing digital metering beyond the technology itself, because the technology is probably really the most straightforward thing about digital metering. We started a business case back in 2016. And that business case came about because of 3 business problems that became apparent. We experienced far too many OH&S issues with our meter reading, our physical meter reading. That's why I've got a picture here of a vicious dog. I'm sure you all recognize that issue, that we have dogs and angry customers, snakes and spiders, and all sorts of issues that meter readers have to deal with. So digital metering became a way to eliminate that OH&S hazard. But that by itself wasn't sufficient business case. And the second image alludes to leakage in our systems. Our systems are running, based on the information that we do have, fairly efficient, but we didn't really have sufficient data to make that a firm statement, because we read our customer meters, the physical meters, every 3 months. So it's like looking at your bank account once every 3 months and then trying to figure out where your money goes. That's not possible. So digital metering became a solution to that problem as well. And last but not least, and where actually most of the financial benefits is in the modeling. The image you see there, that's actually a game that we play with students in our region when our education staff go out, where we ask students to build a network. So our network modeling is probably will be the biggest beneficiary of this digital metering data, because a lot of our network modeling is based on assumptions and statistics, and a lack of information also forces us to add in quite large safety factors. That means that we are perhaps over-investing in our networks, or we're investing too early in extensions of our network. So that formed our business case. And with that business case, we started our journey of digital metering. So at first, in roughly 2016, we had this needs identification. It wasn't really yet a business case. We had these three aspects of these three benefits that we wanted to achieve. And with that information, I went to the executive and I said, I think we need to do digital metering. But you need to let us to take a leap of faith. You need to take a leap of faith and go on this journey with us, because we don't quite know yet exactly where this is going to land. And what we did, we went in head first. We started an expressions of interest for the industry to provide us proposals to do digital metering for our whole region. So indeed, our executive did take a leap of faith, and we decided we don't have to do any trials, because lots of other water utilities have already done trials, and we believe the technology was proven. But the expressions of interest was a way to shake up the market and shake the tree and find out what information is available, what products are available. It was quite an amazing group meeting we had with the people. We sent out 31 documents. We assessed 13 submissions. And from those 13 submissions, we ended up with 4 pre-selective tenderers, because there's still a lot of companies that are not quite ready yet to deliver this service reliably. Now, in a sort of slightly reverse world, we built the business case after we had the selective tender. That was part of that leap of faith. The reason we did this is because this is innovative on certain territory, the leap of faith again. So we used the information from the 4 selective tenderers, and all 4 of them, we interviewed them in a very open 360-degree view, asking them, what would the perfect contract for you look like? And we told them what we wanted to achieve from this. And we built this business case. Part of the business case is that all we asked these tenderers to deliver is to provide us with a daily data dump of the meter reads. So we didn't want an end-to-end process. We just wanted the data because we have sufficient capabilities to plug that in ourselves, and I'll show you more about that later. And we did do a trial phase in the contract. Because of the leap of faith, we had to build an escape hatch in the contract. So we had phase 1, which was completed a few months ago. And there was 1,300 meters in 2 of our most water-stressed systems. So we have data early for those systems. And now we are now getting ready for in February to start full deployment of the remaining 76,000 water connections in our region, which we'll do over a period of 4 years. So that's where we're at with our project. Now, the internal organization for this actually became the biggest issue and the most complex issue that we're still working through. I'm not saying that we have the perfect solution, but it's been quite an interesting learning journey. So we divided this whole project into 10 individual sub-projects, which we call works packages. And when we look at this whole project team that sort of vaguely is available on the slide to you, Coliban Water has about 200 full-time staff, and about 10% of our staff across the whole organization from any department is involved in this project directly, and probably up to 15% indirectly. Because early on, when we started to look at what is hourly meter reading compared to 3 monthly meter reading actually do with our business, what internal processes other than meter reading, other than modeling or water leakages have to be changed? What does this mean for our customer interface? What does this mean for the way we deal with data? What other services can we provide to customers that we don't have? What existing processes need to be changed? So, and the more we looked at it, the bigger it became. So we have a works package for implementation, which is the contracts management part of it. And that's one of the works packages that I'm running. Then our IT manager looks at the meter asset data architecture, because we are developing our own software to receive the data, to store the data, and to analyze the data. Part of that works package, another works package related to this, is the validation of the digital metering data, and those two packages we are completing. We have another works package which looks at monitoring of the data. So once we receive a lot of data, how do we know that the data is accurate? How do we pick up defective transmitters? We recently had a customer who accidentally or otherwise damaged the meter, and then we received signals for that. So we're building different reports to validate the data. Most importantly, what I'm going to be looking at once the contractor starts again in February is benefits realization. Because having the data is one thing, but actually realizing benefits with the data, that's what it's about. The data sitting in a database will not do anything. So we're looking now at, we built a base analytics package, which we did in an SQL database. And the next step for benefits realization will be more complex analysis. We'll be looking at what else we can do with this information. Our whole billing infrastructure needs to be updated. And one of the things we had to do is, previously, all our water meters were in Hansen, in our asset management system, as 19 pooled assets. So for the town of Bendigo, there was one asset called customer water meters. For each town, we had one asset called customer water meters. We are now splitting those up and doing an asset inventory, and we're receiving a lot of unexpected benefits, because this is the first time we've done a detailed inspection of actually our meter fleet. And related to this is that we are, another project that we're doing as well, we are suckers for change management, because we're also implementing a new billing system and a new CRM system. And obviously those three projects are quite closely intertwined. Our new connections process needs to be reviewed, because we are fairly unique perhaps in the water industry, but any plumber that works in our region can do a new connection. Now, how does that new connections process what does that need to look like in a digital environment? What do we need to change to make that happen? The customer value proposition. Many water utilities talk about digital meters in customers first, and customers first, that's exactly what I'm about. My dissertation is about customer centricity, but I believe a digital metering project is first and foremost information for us to deliver cheaper services to customers. But we're also looking at what does that front end look like to customers? Will we give customers raw data and serve them graphs, or are we going to do something more interesting? The leading on to that is better business practices. What other business practices do we need to change? Do we need to update in order to extract the maximum value, squeeze the last drop of value out of this data? And wrapping all this up is a lot of change management, because the current position that we have in our business called meter reader in 4 years' time will no longer exist. So what are these meter readers going to do? Some of those people need to become meter technicians, because this system will require some maintenance. But other meter readers, we might have to find other jobs for them. And that's also a process we're going through at the moment. But in the implementation, we have a very strong focus on customer engagement for each of the towns that we go to. So we, as Coliban Water, we have about 78,000 services. Probably half of those are in Bendigo, and the rest of those is sort of sporadically distributed across our service region, with the smallest water system having 6 connections, and the largest being Bendigo, about 45,000. But what we decided to do is we're going to contact every single customer about this project. We are going to visit every town, and in some cases clusters of towns when the towns are close together, what we call your town visits. And they've been very successful. So here's a picture of my 2 colleagues this happened to be in Wedderburn, where we go out with our fancy table. We have a model of what the digital meter looks like. And we invite anyone in town to just show up. It's not a forum with questions and answers. It's just you walk in, ask your questions, and then you walk out. This is an engagement technique that we use all the time. So we're sort of tapping into this existing cycle of your town visits. And it was really valuable to do that exercise because people were quite interested in what we're going to do with it. Nobody that we spoke to directly had really any negative feedback. Some people told us, why didn't you do this earlier? Because it is important to save water. And we had some good chats with people about how the technology works. And some people are more interested in the technology than others, but it was really valuable to have that face-to-face interaction with customers that otherwise we don't need. But there is a group within Australia. I don't think they're very large based on our experience with them. They're called Stop Smart Meters Australia. If you're interested in this topic, I recommend you Google them and find out what they're all about. They have a website and a blog with fairly regular articles. 2 of those articles are about digital water meters. This group started as part of opposition against the smart meter project that was rolled out in Victoria a few years ago for electricity. And their objections are quite strong. Dare I say that their objections are largely irrational, but I think that's not the point. The biggest objection these people have is the potential impact to their health, the negative impact to their health. So these people believe that any type of microwave radiation, no matter what level it is broadcast, will negatively impact their health. So the Stop Smart Meters Group Australia has, we had some direct contact with them and tried to explain to them this technology. What we found that it's, you will not be able to convince them otherwise. They are quite set in their ways. When we were going through this in first instance, we were also submitting our pricing submission to our pricing regulator, and Stop Smart Meters Australia asked their members to send an objection letter to the Essential Services Commission. These people sent objection letters based on health impacts, and our financial regulator is not a health regulator, so that was fortunately ignored. But we do have to deal with these issues. The group has also published a PDF file that people can print and stick to their water meter with a bit of a legal statement that says that we are not allowed to install a smart meter. Now, how do we deal with this? We are working on a opt-out process for what we call conscientious objectors. We haven't quite worked it out yet, but what we're trying to do is to give people an opt-out, but provide a bit of a hurdle so that it doesn't so that our coverage for smart meters still becomes large enough. So that was an interesting experience in itself, to having to deal with a group like this. Now, from humans now to computers, so database development. This diagram here, for those of you who work in IT, this is how our internal database fits together. So we received the raw data from Vianet, our service provider. I haven't even plugged their name yet. So Vianet, the Ventia company, they provide our digital meter solution. And what we have done is we then link that information to our asset management system and to our customer system. And with this group of tables that you see here, we are able to provide quite extensive reporting through our existing business. I saw my microphone just went off, so I hope you can still hear me. So data science ethics. I mentioned previously that we dealt a lot with the smart meters, with the Stop Smart Meters Australia. So that started me thinking about data science ethics. And going back to my research experience, I sort of remembered the 3 principles. Informed consent. We are not able to give people informed consent about whether they participate or not. So that's why we decided we need a conscientious objectors clause to help people to come out. Avoid harm in collecting data. So what we see here is a diagonal curve for a random smart meter that we installed. I just picked a random property that I knew was a residential property. And what we can see here, I can actually draw quite a few conclusions about this person's or these people's lifestyles. There's a tiny little bump at 3 in the morning, so I know that this person, over the week that we sampled this data, went to the toilet at least once. I know that at least one of those days they weren't home all day because there's 0 water consumption. We know that they are probably not working or working from home because there's usually always water consumption during the day. So this simple little graph allows me to extract a lot of private information about these customers. And what we want to do is to avoid harm with that. In other words, we are developing our reporting systems in ways that doesn't allow us to spy on our customers unless we have a good reason. Algorithmic fairness is a concept that's being developed in data science, not very well developed yet, but what this is about is how we use the data. And 2 of the questions that are interesting to us is that, will we use this data to police people when we have water restrictions? Is that an ethical way of using this data? My personal view is that it perhaps it's not, because our value proposition that we propose to customers is not about policing them, it's about helping them. So algorithmic fairness is about how do we use this data? What do we allow ourselves to do with this information? And this data science ethics discussion is an ongoing discussion that I recently went to a data science conference, and also there ethics was mentioned a lot, but nobody really has an answer yet on what data science ethic means. Asset management. So we set up a whole new asset management structure, as I explained before. Every single water meter is now being inspected. We take a GPS coordinate. We actually check the serial number and check the model, because often that wasn't correct, what we thought it was, because we used our billing system as our asset management system. And our meter readers become meter technicians. And also our contractors have to be educated on how to replace a digital device and how to install a new one, etc. So lots of asset management implications. So conclusions, so finish this off. Digital metering requires a whole of business approach. It's the only way that you'll be able to extract value from it. Yes, the technology is there, and it can be complex, and it can be there can be digital issues, as we know. But in the end, just collecting data is not the same as achieving benefit. So it's not a technology project, and although we think as water utilities that we are engineering firms, we don't sell water, we sell customer experiences. So also in this project, it's not about the data, it's about the experience we have with the data. So my advice for anyone is to focus on the outcomes. Don't focus on the technology, focus on what you want to achieve with this information. And then I believe you can build some real value. So I'll leave it at this.
Great, thanks for that, Peter. Really insightful presentation there on Coliban Water and their smart metering journey. As a reminder, you can ask questions of any of our presenters. Just use the chat box on the right-hand side. Our second speaker is Howard Whitten, General Manager of Network Management at Queensland Urban Utilities. And Howard will be discussing QUU's pursuit of intelligence in their water network. Howard, if you can unmute, thanks.
Good afternoon, everybody. Howard Whitten from QUU. So pursuing intelligence in a water network, and I think we're all trying to sort of put some intelligence into our networks. Quick profile of Urban Utilities. We're a large water and sewage provider in Australia. We have a fairly diverse service territory. We've got a lot of regional areas and a fairly densely populated metro area in Brisbane, which spreads into Ipswich, and then it gets a bit more diverse into the rural areas. Service territory is about 14,000 square kilometres, and we've got about 1.4 million customers. The chart shows it. We've got 19,000 kilometres of pipeline, both water and sewage, and a series of obviously big fixed assets and pump stations, reservoirs, etc. We've got about 1,000 employees and, like we say, about 1.4 million customers. When I was asked to do this, it was about where do we fit. So we created a strategy about 18 months, 2 years ago, and I thought I would share just a bit of that journey. So we looked at the model and we used the SWAN model about how to sort of embed intelligence into our operation, and we created a strategy about it. The target for our strategy is that we move away from being a reactive organization, which is our traditional sort of operating model, and move to a more proactive and predictive. What we're trying to get is better outcomes, like the previous speaker. It's actually about the outcomes we're trying to achieve for our customers. So in our organization, we're really trying to improve our customers' experience by delivering a consistent supply of water and increase the quality, so they rely on us to deliver it. And that's a trend that we're seeing increasingly as we move forward. Customers' expectations are increasing. At the same time, we want to be able to do that at a lower cost for our customers. The cost of living is a significant impost in what we do, and we recognize our part in it, and we're trying to create better outcomes and reducing the cost. Our approach is, when we bring new technologies in, is we're trying to sort of start small, implement it fairly quickly, be fairly nimble, learn from that, and then either stop, learn, or expand and put more in. We find a range of some technologies, and we've had some issues historically where we've gone big and been not necessarily down by the whole of the technology, but some of the things that it relied on. We had one fleet we rolled out, which was based on the 2G network. And when the 2G network folded in Australia, we were left with a series of stranded assets. So there is an element now where we look to sort of start small, really understand the technology, and then learn from it and roll it out. When I looked at this, I went, where did our journey really start in terms of the network? And I like to sort of trace it back to when the Millennium Drag took part in southeast Queensland, which was late 90s through 2000. It was clearly a long, protracted drought. Before the drought, there was this large consumption per person per day. And through the drought, we had a program of pressure and leakage reduction, and we targeted 20 meg a day. What that delivered for us was 120 DMAs, about a third of the Brisbane City Council area, and a fairly large capital cost. Why did I use that as the starting point? Is that we actually created a lot of data points and a way of managing the network, and we did reduce pressure and we did get the leakage, but we were probably not active in the way we managed it. And so as time's gone on, we've tried to create more intelligence from it and really leverage off this asset base. So our challenge is, how do we use intelligence to support a customer-centric approach to operating our assets? The diagram at the left is an internal diagram that shows 4 strategic goals and the customer at the center of it. And in context of this, the foundational success is about that we consistently deliver good quality water for our customers. So we've got Takadu as part of our intelligence framework. It's a key tool in delivering reduction in non-revenue water, and it's the tool that we use to manage the large volumes of data we get now in terms of managing our DMAs. When we first had the DMAs installed, and for a number of years, there was a lot of manual intervention and interpretation of the data to understand where we would go to identify leaks. When we introduced Takadu in 2013, we effectively started to use a tool and some intelligence in that tool to direct us into how to really manage the DMAs and target areas and find the leaks, etc. Our journey started in 2013, and we piloted 2,000 kilometers across our network. And then by 2018, we've increased that to 4,500. So we now cover all of our DMAs. And as you can obviously tell from previous slides, we don't cover the full service territory that we have, and that's an area we'll look to move to. Since we've been using Takadu, we've saved 6,700 megalitres of water. And what does it create for us? It helps us drive down our unplanned repair cost, our emergency response costs, We try to get to leaks early and manage them, and that's a growing trend as we move forward, is how do we get to that predictive and planned piece where if we can find a leak, get into it early before it creates a burst and creates that responsive space. With TACADO in place, what we're now in trying to achieve is to get further and better data sources into it, and increase the usage of TACADO as our tool of choice. And so some of the examples I've now got to sort of move forward are areas where we're trialing devices and trying to get low-cost data sources so that we can actually really leverage and utilize more from our TACADO system. So one of the examples we've got, we have 3 large trunk mains. The little map in the corner shows 3 locations on trunk mains that are the main arteries for the CBD in Brisbane. And they historically have not had flow meters on them. And so we needed to put in some flow metering, and what we've installed is 3 clamp-on Flexum flow meters with 3 I2O loggers, which have been very low cost for us. So in real terms, about $100,000 for the 3 installations, which compared to a full-scale flow meter with switchboard and RTU, all of the things that go associated with it, we put these in, and they've been successful. We now have 3 flow meters. In terms of a little photograph, it's the head part from the Flexum meter, the I2O RTU, and a small car battery, and that's backed up with a solar panel. The reason we went for that model is the standard for the I2O RTU is to 4 reads a day, and for polling. We wanted to just have better access to the data, and rather than just kill the battery, we've created it with a small car battery, and it has a solar battery that keeps it charged up so that we can keep pinging the system and get the data more frequently. Some of the successes we've had, and I'll put it out there, we found a trunk valve that wasn't fully open, so it was in the wrong position for us. And what that does is it effectively reduces the resilience into the CBD. So although the CBD was getting fully supplied, one of the feeds wasn't fully servicing it. Without having real flow data and the ability to identify it through these flow meters, we'd have struggled to identify and find that. We've since clearly gone in and fully got that valve into its correct position. That ability to get real data and really informed information, even as something as big as a trunk main, has been pretty much invaluable to us. Another device we've started to really roll out is the Point Orange from Metasphere. What we're using those for in the water sense, and we also use them in the sewer networks as well. Maybe use that for a different discussion. But what we have the ability to do now, and we've done it, is to create DMAs where power is sort of limited. So in one of our rural areas, we've created 54 DMAs, and some of the areas don't have power available, and so we've created, using the Point Oranges, effectively an RTU, and it's a choice for us. It integrates well with our SCADA system, so rather than it go to its own cloud installation, we have it coming into our SCADA, and then that data is then on-fed to TACADO. So we've created a very low-cost way of delivering data and manage that system. Clearly, the cost of installation is much less. Typical price for the Point Oranges is about probably $2,500, and then there's coding and some installation work. What we also use them for is to monitor the local network when we do planned outages. As part of when we do local trunk network sort of relocations and rezones, we'll put a series of Point Oranges out in the network so we can actually monitor the performance as we execute a trial and execute a shot, so that it delivers what we modeled it to do. And we found we're getting much better at maintaining the supply and understanding, because if during a trial it goes off, we can then curtail a trial and work out, because there may be a valve closed that's sort of killing part of the network. By having multiple eyes on the network, it allows us to operate it more effectively. In terms of the rural environment, the population there, it's about 11,500 customers and about 500 kilometres of main, created into sort of the 54 DMAs. And it's been really successful. It's been a great way for us to move it forward. Next question is, what can we do for quality? The other part of our service offering is obviously the quality of the water we supply. In 2015, we introduced a program into our business to improve the disinfection at our storage tanks, and we needed to know how that was operating and where we were getting disinfection across our network and were there any issues. So we started again with a small fleet of the chloroclams. These are a battery-powered GPS 3G unit with a small chlorine sensor on it, and it's allowed us to get real-time data or near real-time data on our chlorine levels in our network and at our reservoirs. We commenced with a small fleet and we expanded, and we currently operate 65 of them at a range of locations, 87. Some of them are movable locations. They are fairly low maintenance devices. They're inexpensive in terms of what we get. There's a versatility to them in being able to either install them permanently or we mobile them. So if we have an investigation fleet, they're discreet, and what we find is we get a quantum of data that we never previously would have had. So our historical model would be a sampler going out and taking physical samples, and in some areas it might be three samples a week. So we're getting dot points. What we now get is time series data on 15-minute increments. We're probably saving about 90,000 a year in terms of our sampling costs. With a large geographic area, we have costs in sort of getting samples taken. So where we are now with having data, we can see the data pretty much real time. My water quality experts and engineers get to look at the data and we can see what the network is really doing. So we get to do real operating decisions on things like deep cycling of reservoirs, how we can configure the network, see where the chlorine is moving, our effectiveness of our disinfection techniques. And we also can engage with customers. On some of our commercial customers, we can put these devices pretty much either on their premise or at our boundary and understand what is the supply we're giving. And we've done some where we've had conversations with some of our significant customers who've had issues, and we've done some combination trunk main cleaning on our network and some of theirs and improved the quality of their product, the water to them, with neither of us really having to do a CapEx solution. It's really been a maintenance activity. And so then is to where next? So we continue to look for different technologies. We're always interested in looking at new technologies and in putting them into our network and seeing how they fit. Starting to integrate the data into different sets of systems. So the use of Power BI and the use of an enterprise historian. We're in the implementation stage of putting an enterprise historian in the business, which will allow SCADA data and some of these other data sources to be brought together, and then the use of BI to try and understand and really put some analytics to it. And then a final stage product that we're really looking to get to bring things together is connecting our SCADA to a hydraulic model as well, so that we can start to get real-time modeling and operation happening. It's in its early stages, but we're kind of hopeful that we'll get a useful product out of it. And I think that's me.
Great, thanks for that, Howard. If you can go on mute, that would be great.
Thank you.
Our final speakers today are from Sydney Water. We have Darren Cash, Customer Hub Manager, and Mike Wessel, Head of Operational Technology, and they'll be presenting about Sydney Water's Customer Hub and IoT. Thanks, Darren.
Thanks, Hugh. Afternoon, everyone. As Hugh said, my name's Darren Cash, Customer Hub Manager at Sydney Water. So we're going to do a bit of a split presentation. I'll give you a bit of a summary of Customer Hub and what we're trying to achieve. And then Mike will go through some of our IoT initiatives which we've done under the Customer Hub banner. So Customer Hub, we've essentially set it up to improve the experience for our customers. Any customers that are either experiencing a service fault, are affected by a service interruption, but also we want to try and avoid any customers falling into that category in the first place, and that's where IoT comes into the equation. So we're really focusing on a couple of things, and very similar to the themes from the last presentation, being proactive in our communications with customers and being predictive in the way we operate our assets. Again, that's where the IoT comes in, but also using some of the SCADA data that we have more effectively. I'll go quickly through what Customer Hub is in terms of people, process and technology. So from a people perspective, we've brought together 4 teams actually now that were previously geographically isolated, and also, I suppose, a little bit isolated in their approach. So we have our team of service faults operators from previously from our contact centre. We have a scheduling and dispatch team that dispatch work to crews and make sure that that work gets completed. We have a team of customer advocates who have a field liaison presence with customers to help customers through difficult situations. Like today, for those that are in Sydney, it's pouring with rain. We've got a lot of customers affected by sewer overflows, and our customer advocates will help them through that situation. And we have our control room, what we call our system operations centre, that monitors and controls the network via SCADA. So they're all now part of the Customer Hub team, and they all have an aligned view of minimising the impact on customers. And to make sure that we have that alignment, there is a 24/7 customer duty manager that ensures that everyone works together in the best interest of the customer. So from a people perspective, that's what we've set up with the establishment of Customer Hub. From a process and a technology perspective, so both the processes and the technology were developed together. The processes that we launched for the hub, we've been running in a pilot phase since September last year, and the pilot area is shown in the map there. It's the western part of Sydney, around 1 million people for the pilot. And we're about to, in fact today is our go live for rolling out that pilot arrangement to cover the entire area of operations. And the things that we're focusing on from a process point of view is minimising the customer impact of water outages. So there were a few gaps there that we needed to address so that we minimised our customer impact. Being proactive in notifications, so letting customers know when there's reactive work that's going to affect them, or where there's a burst water main in their area. We want to be contacting customers rather than waiting for them to contact us to find out what's going on. We've launched a customer experience measurement platform, so now measuring customer feedback in real time, and in addition to that, having a real-time service recovery process that responds to that feedback. And then there's some proactive case management there to prevent issues being escalated to complaints, that sort of thing. From a technology point of view, one of the key things that we've delivered is a tool called Spatial Hub, developed in-house by our digital business team. And that's been a real game changer in terms of being able to reduce the customer impact of our day-to-day operations. We have a SMS notification and email notification platform. We use an off-the-shelf product called Whisper. And that also forms part of our customer experience measurement platform. So each of those things we've had to integrate with our internal legacy systems, And we've also kicked off an Internet of Things pilot, which we'll cover later in the presentation. So one of the real game-changing things, as I mentioned, has been Spatial Hub. It's essentially a geospatial view of all of our internal data streams plus some external data streams. I do normally have some nice little videos as part of the presentation, but given the constraints of the webinar, we've had to pull those out. But to give you a bit of an idea, one of the key features is a real useful connectivity model where we're able to click on any water main in the network, and it really simplifies the operation of the network for an operator. They can click on it and not just see what customers are directly connected to that main, but the customers that are reliant on that main to provide service to the area. So there was just one example there of by isolating one particular water main, we could affect 700 customers, and this tool shows that to the operators straight away and allows them to model what the impact of a rezoning might be so we can reduce the impact. We're doing proactive communications, as I mentioned, for water interruptions, so it's via text message. The text messages have some rich message content, so you can link to sort of web-like content. And as I mentioned, that's part of our customer feedback that we get. So there's a Net Promoter Score style survey that we use to get feedback in real time from customers. We have a dashboard that we use to track that customer feedback, and we review that every day in the hub and go through what we can learn from the last 24 hours of feedback and whether there's some ongoing themes and how we can improve the overall experience. In terms of some of the results we've been able to achieve, so as I said, we've been running in pilot for the last 12 months or so, and using some of the functionality that's in Spatial Hub as part of our planning and also in response to reactive work. We've been able to avoid affecting over 60,000 properties that would have otherwise been affected by water interruptions. We've launched online channels for customers, so an online leak reporting form. There's been 14,000 leaks reported through that. There's some other stats there about the number of customers we've proactively notified, number we've kept informed, etc. The Net Promoter Score, or the score that we're using to track customer sentiment, I'll leave it up to you to Google Net Promoter Score if you're not familiar with it. It was 48 when this presentation was, or when this slide was put together, but it's now sitting at 50. That's actually a very healthy Net Promoter Score. But I think probably the biggest benefit has been really co-locating those teams and seeing a real cultural difference and an alignment on minimising the impact on the customer and improving the overall experience for the customer. But as I mentioned, it's not just about communications with customers, it's also about being predictive in the way that we do things, and part of that has been our IoT pilot. And so I'll hand over to Mike, and he can take you through what we've been doing there.
Thanks, Darren. So my name is Mike Warsall. I look after operational technology at Sydney Water. So historically, we've looked over SCADA systems and wide area network telemetry. We've been doing that for about 25 years, and it's mainly covered our trunk network, and it's done it quite effectively. But we had a vision to go to change, so we had a drive for change, and my CIO, George Hunt, had a vision for a hyper-connected utility, which was everything will be connected to everything else: workforce, assets, customers, regulators, shareholders, and everything that should touch either of those things. And the bottom of that slide is the key thing, and that's what Darren started this with. It was to go from being reactive to as proactive as we can be and predictive wherever possible. So we had a whole bunch of different use cases that we identified early on that we might use to support Customer Hub in delivering good customer outcomes. We picked 5. We actually went with 4 of those. The valve position one we haven't really pushed at this stage for a range of reasons, not least of which it was challenging. We went with smart meters, sewer blockage detection, sewer overflow detection. water pressure change detection for a range of reasons, and valve position because it was a challenge for us in understanding where valves were. We have a lot of unmonitored valves. We developed a high-level architecture, and I'll probably spend more time on this than any other slide, so I'll quickly take you through what we did. We had a range of devices on the left-hand side that we sourced from the general marketplace from vendors, or built ourselves, and we'll come to why we did that in a second. We used 4 different low-power wide area network technologies for the networks, and it was more about finding out what benefits each of those could provide and what level of depth of coverage they give us. Excuse me a second. We also used traditional ICATs, which was 3G technology, which is the bottom of that, which is our standard SCADA system. We fed the data through a broker, or data ingestion engine, which happened to be Cumulosity, which we were using from our partnership with Telstra. We fed that data from there as a single stream, so regardless of whether it came in as low-risk Sigfox, Taggle, or NB-IoT, it went out as a common IoT stream to an Azure platform, where our own internal teams developed a range of tools, and we visualize it through Spatial Hub that Darren has just mentioned, or Power BI. So the configuration database at the bottom of that slide is what we use to configure the devices and all of the additional systems. That's pretty much what we did as the trial. Key outcomes, everything pretty much worked. So all the technologies worked, I wouldn't say as required, but they worked. So including smart meters. So we had approximately 330 sensors installed. 225 of them were sewage blockage sensors, 45 water pressure gauges, 60 other devices, so they were ultrasonics, overflows, level sensors, and about 80 smart meters of different types. And they're using all of the different networks as well. And there are a range of technologies from standard pulse to full-on digital ultrasonic meters with pressure and temperature. We've discussed the gateways. We also stood up our own LoRa network, and we shared that with a range of councils and universities as part of this trial. And the outcome of that was to select preferred solutions across all of the technology streams. So we're currently, what benefits did we get? We've had about 18 sewer blockages detected. I haven't looked today. I don't know whether we detected a few today, but there was enough rain that it wouldn't have mattered. And the idea was to detect them and clear them before they impacted the customer or the environment. We've had a number of high impact overflows that may or may not have affected properties, but they were detected before they could. We've identified potential alternatives to preventive maintenance, so why send crews out if we can detect it without doing that, as well as detecting improvements to breakdown maintenance. So we've had a number of incidents where we've sent a crew out, they've carried out a breakdown maintenance activity, try and clear the fault, and in fact, we've sent somebody else out the next day. So what we found out is some of those processes aren't as effective as they could be. And we've detected pressure fluctuations caused by water tankers extracting water from systems where they possibly shouldn't have been doing and where they possibly haven't paid for it. So that's the story so far. Some key learnings. It's an immature marketplace. I'm sure there's people who'll tell you that everything's wonderful, but it's not our expectation or our finding, especially for suitable devices for sewer. So it's a challenging environment and not widely available yet. We have quite a high number of failures. The cost of unreliability is critical to the desired outcome. It used to say cost of reliability, but if it's unreliable and you have to send people back to fix things, it's got a significant impact on your bottom line when you're looking for benefits. Logistics and coordination is exceedingly complex in a distribution network and customer premises, so it's a lot harder than standard trunk-based systems. Interoperability doesn't exist at any layer on the IoT ecostructure yet, so you buy a device from one vendor and try and connect it to anybody else's or any other network and good luck. Technology is pretty much at the emergent stage currently at all layers of the ecostructure, and device management is a key consideration. So currently we're using scripting and that configuration database to configure 5 different layers of that ecostructure separately. There's no end-to-end process. And the last one is that most vendors aren't really considering security adequately. It's an afterthought at best. We tried to feed back to suppliers using a non-descriptive mechanism. So the y-axis, the cost is the lower end at the top, and the technical compliance or functionality compliance is the higher end on the x-axis. So it's technical against cost. So if it's in that top right quadrant, that's what we're looking for as the best outcome. We've made it anonymized. So the idea is to give each of the vendors some feedback on where they stand from a functional technical aspect against the cost aspect, and to give them some idea of where they need to move in the marketplace. So we're just in the process of sharing that with each of the vendors who participated. And that was me.
Excellent. Thanks, Mike, and thanks to Darren. That was a great insight there to both the Customer Hub and the IoT journey that Sydney Water's on. And thanks to both to Peter and Howard as well. I'm mindful of the time here, and it is getting late in the day in most of Australia, so we'll go through a couple of quick questions here. And if the presenter can unmute and keep their answers as brief as possible, as to get through as many questions. The first question is for Peter. What have you developed regarding water loss detection with your smart meters?
We have developed a rudimentary leak detection algorithm for customer meters, and we're now in the process of starting to identify individual customers and looking at internal process of how we're going to communicate this to them. The other thing we're doing is we are linking the digital metering to our SWAN metering, and what that is indicating is giving us a lot better information, because we now can do a water balance basically on an hourly basis rather than waiting for 3 months. And in the one system where we've done that, it actually shows us that we probably shouldn't worry too much about leaks, and that we've overinvested in leak detection.
Great, thanks for that. A question here for Howard. You mentioned about your customers' cost of living being a big issue for QUU. Do you believe your customers want cheaper water or better service?
I think they actually want both. We do recognise that our customers have there is a sensitivity to the price of water, and I don't need to go into detail of it, but we do know through our own work with our customers that the price of the water, price of our service, is a sensitive issue for customers, and there is an expectation and a growing expectation of a high quality service. It's a real conundrum. I don't have the easy answer for you, but both of them are real issues for our customer base.
Well, I've got you there, Howard. Another question regarding your chloroclams.
Yep.
What is the main use case? Do they support or replace, usual client sampling?
So they definitely don't replace the compliance. We've got an obligation there, and we maintain that obligation through the use of the chloroclams is really as a process control device, and the quantum of data we get for the investment really allows that process control piece to be undertaken. If you looked at it as an STP, they have real ongoing process data stuff, and they're used to it. In the networks, we're typically not. And so having these devices really allows us to look at the network more in a process sense, but they're definitely a supplement to our compliance piece.
Question also, Howard, around procurement. It seems like you've moved quite fast with your smart water trials, particularly because of their small nature. How have you managed that from a procurement and approvals perspective?
Can I be honest? We just sort of go ahead and do things. I appreciate as big organisations, and particularly ours, we sometimes can create that impression that we're hard to deal with. But genuinely, we have a CEO who leads the business in a sense of innovation. And so we really do try to mobilise quick on things. And generally, if we make it small, we can implement things much quicker. I can't guarantee everyone will be quick and easy, but that's the intent we're trying to get to.
And another question, what is QUU thinking regarding smart wastewater systems? It seems like a lot of your discussion.
Yeah, so part of the presentation that actually took out because it seemed to clash because of the water theme, but we do have a fleet of the Point Oranges going into the sewer network, similar to the Sydney Water case for sewer overflows. and trying to also use them to create a prediction tool for when a sewer needs rather than a cyclic clean, need a preemptive clean. As you start to trend the level of the sewer rising over time, it clearly indicates there's potential for a blockage. So we can go out and do a clean as opposed to doing it on a cyclic, which may or may not be an effective use of the resource. So we're definitely into it. Is it all the devices? It's where we're at the moment. Could we do more? Always open to suggestions from different people, for sure.
Great. The final question here is for Mike at Sydney Water. Curious how the workflow of blockage and overflow prediction is undertaken at Sydney Water. How are assets in the field manipulated to avoid the predicted event? And is remote control of wet weather assets in the development pipeline for Sydney Water?
Yeah, it's a quick answer, probably. The not. What I didn't mention is we didn't get the machine learning aspect of what we wanted to develop as part of the first pilot. And most of those sensors were in there to actually use machine learning to actually inform that whole discussion. We don't currently have that many control assets, so we're not in a position to be able to manipulate them. The idea is to use this trial to demonstrate that there's a use case in doing that.
Excellent. Thanks, everyone. That concludes our webinar today. If you have any further questions for our speakers, please go to swan-forum.com, where you can contact the SWAN Alliance, and we'll get those questions answered by our presenters. Again, apologies for the commencement and the late change with the logistics of setting up the webinar. We hope you all enjoyed it, and we look forward to connecting with you early in 2019. Thanks.
Thanks, Hugo. Bye.